Good evening, everyone.
Yeah, good evening, sir.
Okay, so this is the session, a revision session for statistics week 2. So we'll be just looking over you like whatever was taught in the first 2 weeks of the course. Okay, so we'll just start the session. In the meanwhile, I'll just mute everyone.
Hello.
Yes.
Good evening, sir.
Yeah. Good evening.
So I have doubt in correlation.
Okay, so basically, this is a revision session. Time permits, I'll see at the end of the session if we have some time for doubt clearing. Okay, this is just revision session where that is in week 3 and 4. So basically, this is only for week 1 and 2. Okay.
Okay, sir.
Okay,
So
you can always
yeah.
you can always join those doubt clearing sessions that we have. So you can ask your doubts there. Okay.
Okay, sir.
Sir, week 3 and week 4 sessions, revision sessions, when will it happen?
Yeah, tomorrow.
Okay, sir.
It will be held tomorrow. Okay.
Yeah, it has been updated, sir.
Yeah, they're updated.
Yeah, it is updated.
Okay. So let's.
Today it's a stat week 1 and 2.
Yeah, this is statistics 1, week 1 and 2 revision
Yeah.
session.
Yes, that's perfect. Thank you.
Okay. So, okay, so now we'll start the session. Okay. Okay. So basically in this session, we'll be covering the first 2 weeks of statistics 1. So let's get started with the session. So, okay. So basically starting from the beginning, like first of all, what we need to know, what is statistics? Like if we are studying statistics, this course is statistics 1 for data science. So first of all, we need to know what is statistics. Okay. So how statistics has, you can define it in many ways, but how it has been defined here is that statistics is the art of learning from data. Okay. Whatever we have data is just a collection of observations around us. We got all of that data. Okay. So it is concerned with what is statistics concerned with? We learn from data, but how? We collect the data, we give a description of the data, we analyze data, and we conclude from the data. Okay, so basically it is all concerned with data, learning from data, collecting the data, like summarizing the data, and using that data for further analysis or conclusions to make conclusions about like a bigger population and all that. Okay, so there are basically 2 major branches of statistics. One is called descriptive statistics, another one is the inferential statistics. Okay, so let's get to the first one, that is the descriptive statistics. Okay, so descriptive statistics, as has been described, is the part of statistics concerned with the description and summarization of data. Okay, in this what we do is we basically we have data, we just describe it, we summarize it, like whatever, how we summarize the data, what is its like most frequent occurring observations, what is the central tendencies and all that. Wait a moment, I'll just, there is a lot of disturbance, I'll mute. Okay, so Now, getting to descriptive statistics, like I mentioned, descriptive statistics is the part of statistics. It is that branch of statistics which is concerned with the description and summary data. Okay, so what do we do in summary of the data? What we do, like we see its most typical value, we see what is its central value, we see what most common occurring value, and that is how we like mostly describe the data, how the data is spread throughout. Okay, so that deals with the descriptive statistics. Coming to the second part, that is inference or inferential statistics. So what this branch of statistics is concerned with, it is basically concerned with the drawing of conclusions from data. Okay, so basically we have a smaller set of data. For example, this is my sample, and I have a sample of the population. You can think of it as a population, and sample you can think of it as a subset. Okay, we have this sample. So what we do is we draw conclusions about the population on basis of whatever we got from the sample. Okay, so sample must be really good representative of the population. Okay, so when dealing with inferential statistics, we basically take into account the possibility of chance. Okay, so when we get with chance is basically probability. So we'll deal with inferential statistic in the later part of this course, and like when we get to probability. Okay, moving ahead. So like, what do we do in the description? We understand the characteristics of the particular data set. Like, we will be given a data set. What we'll do is we'll understand the particular characteristics of the data set. So like, just we summarize the data and we describe it. Okay, now coming to inferential data, inferential statistics. What do we do in inferential statistics? We basically have some data. Okay, we have some data like all clear now. Okay, so moving ahead, is the voice clear now? Okay. Moving ahead with inferential statistics is we use what we do is we use this sample to make predictions or conclusions entire data set. Is it clear now, voice? Is it clear now? Is it clear now, voice? Okay, so moving ahead. Okay, so now we are going towards inferential statistics. Okay, so what we do is or draw conclusion about the larger population. For example, like I just said, this is our we take a smaller subset of the data, that is the sample, and what we do is we perform statistical analysis about the data, the population. Okay, is it clear now? Yeah, I guess it's internet. Okay, it's clear now. Okay, so now it's clear. Okay. Okay, it's fine. So basically, I'll just start over. So, statistics, okay? One is descriptive and other is inferential. So let's first understand what descriptive is, like I mentioned earlier. So what we do in descriptive statistics is we understand the characteristics of a particular data set. Like we have been given a data set, we understand what are its characteristics. Like we understand what is its most typical observation, what is the most frequent occurring observation. We see what is the middle value of the data set. We describe the data in descriptive statistics. Okay, now moving on to inferential statistics. So what we do, like if we have a data, this is our entire data. Sorry, if we have our entire data, we call it as the population. Okay, if we take a smaller subset of that data, this is the entire population. Population means the entire data. Okay, so what we do is we take a subset of the data. You can think it of as a subset, and we call this as sample. Okay, so in inferential statistics, what we do is we use this sample. We use a sample or the smaller portion of the entire data to make predictions or draw conclusions about this population. Okay, so this part is dealt with in inferential statistics. Chance. So when we take in account the possibility of chance, we are introduced to the concept of probability. Okay, that we will cover in the later parts of this course. Okay, now moving ahead, population and sample. How do you know what is population and what is sample? Okay, suppose we are interested in knowing the percentage of all students in India who have passed their class 12 exam and are studying engineering. Okay, percentage of students who have passed their class 12 exams and are studying engineering right now. Okay, or we are like, for example, in Tamil Nadu, we want to know what is the price of all the houses in Tamil Nadu, or for we want to know the total sales of cars in India in the year 2019 or 20, in any year. Or we want to know, for example, if there is a city mall or something like that, we want to know what is the distribution of people, age distribution, like of what age category do people visit the mall. Okay, so population, now we'll move to population to understand, like, we can like we need to use them. Okay, so basically what population is, it is the total collection of all the elements that we are interested in. Okay, so for example, if this is our data set, the entire data set, if we are this is our population. Okay, we are interested in like the total of the all elements, that is called the population. Okay, now moving to sample. What is sample? Sample is a subgroup of the population that we study in detail. Okay, for example, like I just mentioned, if this is our population, that is the entire data, this is our population. Okay, and we want there is a subgroup, like you can think of it as a subset. Okay, this is our we call it our sample. Okay, it is a smaller, a subgroup of the population. The entire data, we take some part of data, so we call it as sample. Okay, now why do we need sample, and why do we like need what is the need for sample? So in some cases, in certain cases, what is the case, right? There are certain practical cases in which it is not possible for us to go around and collect the entire data. Okay, So in that case, what we do is we take some subgroup of the data. For example, if we are interested in knowing like the total number of males in India at the moment, it is not practically feasible to go around and like collect the entire data, right? So what we do is like we take a sample. We want to see basically the ratio of males and females in India. For that, we need to calculate. We need to know how many males there are in India and how many females there are in India. So that is not practically feasible, right? So what we do is we take a sample of that data. Sample like what we take a sample. In sample, what we do is we take a subgroup of the data. For example, we'll take a few individuals, a smaller data set from North India, smaller data set from South, from East and West. Then we will study it and we'll like draw inferences about the population. Like if we get the ratio is 1:2, for example, we'll say, yeah, like we got it in North, West, South and East. We'll say, yeah, throughout the India, this we can conclude that the ratio of males to females is 1:2. Okay. In this case, we did not use the entire population, entire data, because it was not practically feasible to get that. So what we did is we collected a sample of that data and we drew conclusions about the population using that sample. Okay. Now, when do we use like inferential statistics and when do we use descriptive statistics? So if the purpose of analysis, basically what we do in statistics is we analyze the data, right? So if the purpose of analysis is to examine and explore the data for its intrinsic interest only, we use a descriptive statistics. Like we have to like use the know the typical value of a data set. We have to know what is the most occurring value of the data set, or what is the middle value of the data set. So we get this from the data only. It's from its own, it's intrinsic to the data, right? Data set. So in that case, the study becomes descriptive. Okay. Like we calculate the mean, the median, mode, standard deviation. We are just summarizing the data. It is the summary of data. It lies within the data, right? It's intrinsic to data. So in that case, the study is descriptive. Okay. Now moving ahead, if the information is obtained from a sample, like I just mentioned, if we obtain the information from the sample and we draw conclusions from that sample about the population, then the study is inferential. Okay. Like we have, like I just mentioned, I just showed in that diagram, if we have a smaller subgroup of the data and from that subgroup we make inferences, we make conclusions about the larger data set. So in that case, our study becomes. Now, a descriptive study may be performed either on a sample or on a population, because sample will also have some data values that are intrinsic to it only. Okay. We can perform descriptive statistics on that. We can, like, if we have a sample, we can calculate its mean, we can calculate its median, and we can calculate its mode. So what we want to say here is that descriptive study we can perform either on the sample or on the population. Okay. But on the other side, when we make inference about the population, we make that inference, like we are making an inference that has to be made from a subgroup. Okay. So when we made inference about the population, about a subgroup of the data set, then the study becomes inferential. Okay. Now, what we like, I'll just summarize what we did till now. We basically first described what is statistics, and so there are two major branches of statistics. One is descriptive and another is inferential. Then I gave you an example like what is descriptive and explained how, like what we do in descriptive statistics and what is done in inferential statistics. And then we covered the concepts of population and sample. Okay. Now, moving ahead, what is data? Now, I have been using this term over and again, data, and data. What is data? Like, what is data is basically, it's nothing. Data is the facts and figures collected. Now we collect facts and figures. For example, number of students in 12th class in India at the moment. We are collecting some facts or figures. It would be, for example, let us say there are, for example, 20 lakh students. So it is a figure that we have collected. So now what do we do with that? We analyze it, we summarize it, and then we present it. And we basically interpret it. So data is very intrinsic to statistics, right? We are doing analysis in data statistics. Analysis of what? Of the data that we get. Data is every information that we have around us is data. Data, we hear this term a lot now, data. Data is nothing, it's just any information that is around us. Okay. Now, why do we need to collect data? Basically, yeah, we need to perform the statistical analysis. For that, we need to collect the data. We need data to collect, like data. Either we, sometime in our case, the data might be provided, but in some cases we need to collect the data, right? We are basically, why do we need to now collect it? Because we are interested in characteristics of some groups or group of people, right? For example, right now we were interested in knowing how many people, how many class 12 students are there in India. So we were interested in a characteristic of a group, right? Of the students, we wanted to know how many are in class 12, right? So we are interested in some things, and for that we need to calculate, we need to collect the data. Okay. For example, if we want to know the temperatures of a particular month in, for example, let's say Chennai, so we need to collect that. We need to collect that fact. We need to collect those figures. So for that, we collect data. Those facts and figures are nothing but data. Okay. Like I was just telling this example, if we wanted to know about the marks obtained by students in their class 12th, it is again facts and figures that we collect. And then we want to know, like, how are the class 12 students performing in India, right? We want to know, like, we want to know what is the average score of males, what is the average score of female students in India. So we are interested in some characteristic of the data. That is why we are collecting the data. Okay. Now, for example, if there are mostly data where we use it, it's in industry purposes, right? It's where it is used on much larger scale. Okay, for example, you, like, there are always new songs, new movies are coming out, or new products are coming out. So for example, there is a new song that is posted on YouTube. So what data can we collect from there? Basically, we can see how many likes it got, how many comments it got, how many dislikes it got. From that we can know, like, what type of song that was. If it was like more liked by people, so we can say, yeah, this was a good song. And we can, like, study how this song or the product or whatever we are concerned with at the moment. Okay. So data collection, now we have to collect data. So how do we collect data? Basically, for example, we need to collect data from either sources that we are interested in. Like, let us say we are interested in knowing the class 12th marks of a group of students. So we need to go and ask them. We need to collect that data, right? So either the data is available to us, that is published data, and that, like, you can see the government publishes the data in its website, data.gov.in. So there the data is published. Okay. So if the data is not available, so then we need to collect the data, we need to generate the data. Okay. For the course of this, throughout this course, we will be dealing with the data that is available to us, and we will just do a statistical analysis of the available data. We are not concerned with generating data or getting it data ourselves. We are just concerned with the data that is available to us. We want to perform study on that data only. Okay. So now data can be of two types. Okay. Unstructured and structured data. Like, now if we have data can be meaningful and it can be, like, meaningless if the data is not structured. For example, you go to a shopkeeper and he gives you this data: 1 2 1 2 3 4 7 8 12. So what sense you can make out of this data? Nothing, because this is not structured. You don't know what this is. You don't know, like, what the data represents. So for the data to be, like, the information, the data to be useful, we must know the context of the numbers and text it holds, right? For example, we have this data M, X, L, S. So if we don't know the context, what does M stand for, what does XL stand for, what does S stand for, we cannot see, like, what it is, what are we using the data for, right? Like if it is given that M stands for medium, okay, medium size, we are deal with the t-shirts that a particular shop sold. Okay. Now, if we don't know if M is medium, XL is extra large, or S is small, we cannot use this data because it won't hold any meaning for us, right? So the data must be structured. Like when the just like I just mentioned, if it is just scattered with no structure, the information is of very little use or no use at all, right? So we need to organize the data. We need to organize the data so that we might be able to make inferences. We might be able to analyze the data properly. We might be able to summarize the data properly. We need to do that. And for that, we need to organize the data properly. Okay. So this is just a few data sets that you can get. Structured data, a structured collect. What is now what a data set is? When we define a data set, what is a data set? A data set is basically a structured collection of data, like the data that is structured. We know the context of the text, the numbers that we have been provided. We know what it stands for, what it represents. Then we call that data, that is structured data, right? And collection of structured data is called a data set. Okay, the data set could now be and the data set could now be numbers, it could be names, it could be roll numbers. For example, if we are storing a data in a school database, there they need, for example, the number of students in this class, or we need the name of the students or the roll numbers. Okay. Now moving ahead, variables and cases. What is a case? Now what is a case? Case is basically nothing, it's just an observation. Like it is the unit from which data is collected. When we want to do statistical study, for example, we are interested in knowing the age of a student, his marks in maths, physics, chemistry of a particular student. So we will collect the data from that student, right? Like what his age is, what his marks in all the subjects are. So we are noting those data values for that particular student, right? So the student becomes our case or observation. Okay. Now, what a variable is, as the name suggests, variable. In this, we can see the first four letters like vary. So something, anything that varies. A variable is that what varies. Okay, and this is the intuitive definition, like we can think of. It is something that varies. Now, where does it vary? It varies across the units. Okay, the units that we have collected, it varies across those units. Okay. So this is formally a characteristic or attribute that varies across all units is called a variable, right? If it doesn't vary, then it would be like, it won't be a variable. For example, if we have a data set like name is X, Y, and Z. Okay, physics marks, physics, chemistry, maths. Okay, in this, if we have the school, if it is for the same school, the school will be, let us say the school is a. We can see this is not varying, this is remaining same throughout all the units. So we won't consider this as a variable, right? Others that vary across these units, they are the variables. Okay. Now case is each, in this, what is in this above example, what case is, it is each student. Well, variable is like the name varies, like it is not same across everyone, right? It is a variable. What else? For example, if we have marks obtained, right? So the marks obtained is a variable because it is varying across all the units. Okay. Now we see the rows, they represent cases. For some this one, like it represents a case, and for some case we have these attributes recorded, like physics marks, chemistry marks, maths marks, the school name. Okay. Now moving ahead, now we have these columns. Now what there is in column, we have variables, there is some type of value that is recorded, right? For example, if this is a variable physics mark, it varies, and we have values, different values recorded for different cases. Okay. Now up to this point, what we have done is we have learned what basically statistics is, then we dived further and we saw what is descriptive and inferential statistics. Then we distinguished between a sample and a population. After that, we saw how data is collected. We identified what is a variable and a case in the given data set. Now, what we have to do is we have to go towards types of data. Okay. Now, basically, what we we first did is basic definitions. Okay, then population and sample. We saw what is a population and what is a sample. Then we do a little understanding of data. Now we have a classification of data. Like data can be classified in various types. Now we are moving towards the classification of data. So basically, at the basic level, data can be classified into two categories. Okay, one is categorical data, and another one is numerical data. Okay, as the name suggests, categorical data. In this, we have this word categorical. So categorical is used to refer to when we have the data that refers to categories. Okay, and numerical data, as the name suggests, is when we have numbers, figures, those that have units. Okay, now going towards categorical data. Now this categorical data, we also call it as qualitative. Okay, it is also called as qualitative because it does not represent any quantity. It just gives us the idea of membership. For example, it gives us the idea of membership, what category one belongs to. It gives us the idea of group membership. Okay, that is for categorical data. Now moving ahead to numerical data. What is numerical data? We have another name for numerical data, like we call it as the quantitative variables. Okay, what it does is it describes the numerical properties of the cases. Okay, and it has proper, like this one I'm going to highlight, it has proper measurement units. Okay, now what are measurement units? I just said numerical data has measurement units, so we need to say what measurement units are. Proper measurement units are, these are scales that define the meaning of numerical data, right? For example, if we have this 1, 2, right now we cannot see like what is the meaning of this data. We cannot comprehend that, correct? But when we have like this 1 kg, 2 kg, okay, this is a unit, right? This is the unit for this. Now we can comprehend, okay, this is 1 kg, this is lighter than 2 kg, correct? For example, if we have 10 rupees, we have 20 rupees, now this has unit. If we didn't have, it was 10 and 20, we couldn't like meaning, there was no meaning to this data, right? But now the moment it has a unit. For example, it either has weight as its unit, for example kilograms, or it has rupees. Now these numerical values, they have a proper meaning. Okay, and these units, that data that these numerical variables in that data table have, they must share a common unit. For example, we cannot have 10 kg and for the same variable we'll have 5 rupees, right? If we are we are concerned with the weights, it must be kg throughout, or it must be grams, okay, or milligrams for that matter. Okay, now moving ahead. Now we have two types of data. Again, we can describe on basis of like how and when we got the data. First one is time series data, and the another was is cross time plot, and then we have cross-sectional data. Okay, time series, like in this we have time and series from the name series. So this data has been recorded over a period of time. This is not the data, it's not instant data, it's the data that we have been recording for some period of time. We have recorded it for over a period of time. Okay, that is time series data. Now what is cross-sectional data? Before getting to time plot, let me just explain cross-sectional data. The cross-sectional data is, it is the data that is observed at the same time. Where same time, what we mean is instant. For example, okay, for example, if we are interested, for example, let's say a company, for example Netflix, for that matter, if Netflix wants to keep a track of its users throughout the year 2020, this is 23, for example 22, the year 22, so it kept the data of its users throughout, it kept a track of that throughout the year 2022, like it kept collecting the data over the entire year. So this is time series data because it is being collected over a period of time, it is being collected over time, right? But now if the same company, what it does is it just collects the data of its users, like how many users we have at the end of the year 2022, like on 31st January 31st December 22. What it is cross-sectional, because it was just collected at that instant. It wasn't collected over a period of time, right? So what time plot, now moving ahead to time plot. Time plot is basically, it is a graph of time series, okay, time series data showing values in chronological order, the order like it has been recorded. It's basically that only, okay? So this is for time series and cross-sectional data. Now going ahead, this is the time series data. For example, if we are keeping track of the prices of potato over a period of time, for example, in this case, we have kept track of the data over a period of month, right? We are just seeing like what is the cost, what is the selling price. In this case, we are keeping the track of data over a period of time, not at an instant of time, right? For example, if in the same case we wanted to know what is the cost of potato at the end of month March, then it would be then it won't be time series, it would be cross-sectional, okay? But since we are keeping track of this data over the entire month, this becomes time series data, okay? Now I'll just give a summary what we studied in this half of this session. We first classified the data either as numerical or categorical, okay? For numerical data, we have a measurement unit, right? We have a proper measurement unit, like for example, I said for weight, if it is 1 kg or 2 kgs, for example, if heights, we might have centimeters or feet. So we have a proper unit for that numerical data, because if we don't have a proper unit, the data would be just meaningless. It won't have any meaning. We cannot like convey any meaning through the data. And after that, we checked for if the data is collected at a particular time point or it is collected over a period of time. That is time series data. And in the other case, it would be cross-sectional data. Okay. So up to this point, we have done like understanding cross-sectional versus time series data. So we have covered this part. We have covered, okay. Now moving ahead with measurement scales, okay. Scales of measurement, okay. So when we have data collection, it has to have either one of these scales of measurement, okay. Either it would be nominal, or it would be ordinal, or interval, or ratio. Now we just saw we have two types of data. One is categorical, right? And the another one is numerical. Okay, so for categorical variable, what we have is like nominal and ordinal data, and for ordinal scales of measurement. And for numerical, what we have is interval and ratio. So this we study for like categorical, and this we have for numerical variable, okay. Going ahead, first let us take up nominal scale of measurement. In this nominal, we can see there is nominal, so it is something like naming. We are just concerned with naming of the data, okay. So when the data for a variable consists of labels or names used to identify the characteristic of an observation, the measurement is considered as nominal. For example, it is considered gender, okay. In gender, what we have either M for male and F for female. So when in this case, we can see that the variable is gender. Gender is varying, right? It just consists of these labels. These are just names given to like identify a characteristic M. We have this is for males, right? So what we are basically doing is we are just labeling this data, and there is no order, like male isn't greater than female and female isn't greater. There is no that sense of order in this, right? So in this case, what it becomes nominal scale of measurement for this categorical variable, okay. Now nominal for what, there are some examples for this nominal scale of measurement. What are those examples? For example, name. It's just a label, right? It doesn't represent any like numerical entity. It doesn't show if your name is X and my name is Y. X is not, there is no sense of logical ordering in that. Board is again nominal, right? Gender, as I just suggested. Blood group, right? O positive, for example, AB positive, O negative. And in this case, like we just have like, this is just labeling of the whatever data we have, the variables we have, we are just labeling it. Okay, in this case is the scale of measurement used is nominal. Okay, now sometimes these nominal variables, they can be numerically coded. For example, like I just showed, if we have this gender, okay, gender, it might be male and it might be female. Okay, in this case, for example, we can numerically code male as 0 or female as 1. Okay, or the other way around, whichever way you like, 1 or 0. So basically in this, like, there isn't any sense of ordering in this, right? There is no sense of ordering. It's just a label on the category we are placing. So we don't have any sense of ordering, logical ordering. It still remains nominal data. We are just assigning a numerically coded value to the category, to the label, to the category, whatever we had. For example, if in this case we are assigning male 1 or 0, whatever. Okay. Yeah, this is what I was just saying. It isn't basically required that 1 necessary, it should be 1 or 2. You can take, for example, 99, 101, whatever you want. Okay. Now there is no ordering in the variable, right? We can see that there is no ordering in male and female. You cannot sense you cannot sense a logical ordering in this thing, right? There isn't any logical ordering in males or females. Okay. Nominal is basically what nominal, to summarize what nominal is, it is name categories without implying order. We don't have any order, right? We have no logical order whatsoever. It's just naming. We are just naming the categories, right? We are just putting a label on the categories, different categories that we have, and we don't imply any order. Whenever we have this case, the scale of measurement is going to be nominal. Okay. Now ordinal, the second for the categorical variable, second scale of measurement that we have is ordinal. What is basically ordinal scale? It exhibits the properties of nominal. Like, we used it to basically name categories, but the order or rank of data is meaningful. Whenever this happens, the scale of measurement is called as ordinal. For example, we have ratings: good, bad, and then we have average. Okay. In this, like, for example, this is a rating for some food item or anything. In this, we can sense that there is a sense of like logical ordering. Like, good is, you can see, like, good is the best, then average lies somewhere in middle, and bad is the worst, right? So we can sense that there is some ordering in these three, right? In this case, well, like, basically what we are doing, we are still naming it, right? We are just naming categories, right? 3 categories: good, bad, average. But along with naming it, there is also some sense of measurement, like there is sense of order in the data, right? The order is now meaningful. In this case, for example, male and female, the order, it was not meaningful, right? But in this case, what it is that now the order is meaningful. Okay, the order means something in this case. Okay, so for example, this is the example that has been given. Each customer who visits a restaurant provides a service rating of excellent, good, or poor. Okay, the data obtained is, they are just again labels on what the ratings that have been obtained, right? Now these are just labels, okay, on the labels on what the ratings. Okay, so now we have these labels obtained that are for these ratings. Now we can sense that these labels, they have some order, they have some logical order, right? It can be ordered with respect to, for example, the service quality. If the service quality was good, then like excellent. If it was very good, then excellent has been labeled, like they have been given the rating excellent. If it was good, so good. If it wasn't good, so the rating that was given was poor, right? So in this case, you can sense that there is some sort of logical ordering in this labeling, right? So whenever such thing happens, we call it an ordinal scale of measurement. It is basically naming. We are again naming the categories, right? But In this case, the categories are ordered. There is a sense of ordering. There is a sense of rank. So this is basically the summary of an ordinal scale of measurement. It is again just a naming. What we do is we name categories, but the categories that can be ordered, that have a definite sense of order. There is logically we can see that there is some order in the data. Okay. So moving ahead now, interval scale of measurement. We saw like for categorical variables, we had two scales of measurement, right? Nominal and ordinal. Now moving ahead to numerical variable. The first scale of measurement that we have for numerical variable is interval scale of measurement. Sorry. So in this we can see that there is this word interval. So we have to look for what it means. What meaning does this interval word convey? Okay. Now, if the data has all the properties of ordinal data, now it has the properties of ordinal data. What are the properties? Like we just studied here, that is, it names categories, but in this case it also this naming of categories, it has some order, like logical sense of order. Now interval scale of measurement, this will possess all these, but in addition to this, the interval between values is expressed in terms of fixed unit of measure. Okay, so in other words, let me put it in other words. So in interval scale, it's that type of measurement scale where the values have order. Okay, uh, and the difference between any two adjacent values is equal. Okay, that is basically what that means, is that the intervals between each value on the scale are consistent and meaningful. Okay, these are just meaningful. The like whenever we have the intervals, they are consistent and they convey some meaning. Okay. Okay, so if the data collected has all the properties of ordinary data and the interval between values is expressed in terms of fixed unit, like I just mentioned above, like I just explained, then we call it as the uh, interval scale of measurement. Interval is always numeric, right? And what we can do is we can find difference between any two values. So basically, like if we go ahead in numerical interval scale, what basically the data is in the first place, the data is numeric, right? So what we can do with this numeric data is we can find out the difference. We can add the two values, but what we cannot do is we cannot find the ratio of two meanings. Why? Because in this case there is no absolute zero. The value of zero is just arbitrary. Okay, what does that mean? That there is the ratio of values have no meaning because the value of zero is arbitrary. So zero does not coincide with the concept of nothingness. That is basically what we mean by saying that there is the absolute zero does not exist, or the zero is arbitrary. For example, in this case, if we have mm, let's take temperature in Celsius. Okay, so we often tend to see like this is zero. Okay, this is 0 degrees Celsius. Does 0 degrees Celsius mean that there is no temperature? No, we cannot say that, right? There is some temperature at 0 degrees Celsius, correct? So it does not coincide with the concept of nothingness. But if we take in the Kelvin scale, okay, in the Kelvin scale, we have minus 273 Kelvin, right? And scientifically, it is assumed that at minus 273, it coincides with the concept of nothingness. So there we will say, yes, it has an absolute zero, okay? For example, if we are now getting back to the Celsius scale, this belongs to interval scale, okay? Celsius. For we can like find out the difference. If we have 20 degrees Celsius minus 10 degrees Celsius, then we have a difference of 10 degrees, right? But ratios, they won't be like very meaningful in this in this case, because we like the zero, it is not like, it does not coincide with the concept of nothingness exactly. Okay, so moving ahead, what is numerical now interval scale? In interval scale, what we do is we have numerical values, right? Now these values can be added or subtracted, but we cannot divide them, okay? Because of this thing, because there does not exist any absolute zero. Okay, this is basically the meaning of no absolute zero. Now, for example, this is the example I just gave. Okay, suppose the response to a question on how hot the day is comfortable and uncomfortable, then it will be just nominal. Like comfortable, we are just naming how the temperature is. We are not, there is no like comfortable might be some for someone it might be different, for someone it might be different. So we are just naming it. We are not, there is no sense of ordering, right? It's just comfortable and it's not comfortable. So we don't have any logical ordering, correct? So for example, now we have moving on to another example in the same temperature measurement. Okay, we have tea. Let us say we have tea. We can say it is either cold, it is warm, or it is hot. Now we are again naming these like these labels, right? We are naming these labels. Okay, now we are naming these labels, but in addition to that, there is some sense of order. Like hot is not the same as, there is a logical ordering. If you think about that, we have hot, warm, and cold. Hot is a little less, like the temperature is a little less than warm, and cold in this the temperature is still less. But we cannot add these. We cannot say cold plus right, or something else. So in this case, like we cannot perform arithmetic operations as subtraction and multiple sorry addition. So this, in this case, the variable is just ordinal. Okay, now moving on to another example. Now we have a room. Now the temperature is set at, for example, when we have AC, we set the temperature, right? So we have set the temperature equal to 20 degrees Celsius, and outside it is 40 degrees Celsius. It would be like, yeah, it is okay to say that the difference in temperatures is 20 degree, but you cannot say this for just let me get there. 40 degrees Celsius over 20 degrees Celsius means that outdoor is twice as hot as indoors. Okay, because like another, like I just said, there is no absolute zero. There is no absolute zero, so the concept of like raking ratios, it does not make any sense, right? So this was for interval scale. Now temperature in degrees or degree Fahrenheit or degree centigrades is an interval scale. Okay, it lies on interval scale. Because why does it? Because we don't have any absolute zero. Zero does not coincide with the concept of, or with the idea of nothingness. Okay, now we have the another, the second scale of measurement for numeric variables. Okay, this is again for numerical variable. Okay, so now we saw interval. So what is ratio? Now in this, as we can see that there is this word ratio, so it must have something to do with ratio, right? Because the term ratio is there. So what happens is, if we have data that has all the properties of interval, what were the properties of interval? Let me get there. These were the properties of interval, right? Numerical values that can be added or subtracted, and like the intervals are consistent or meaningful, then it is interval. So what will happen is ordinal data will have these properties, and in addition to that, the ratio of two values is meaningful. Now in this, the ratio of two values, we can comprehend it as like it is meaningful. It's not like interval scale where we cannot like comprehend the ratio of two values. In this, the absolute zero does exist. Okay, we have like this absolute zero exists. What is absolute zero here? It is just basically that it coincides with the concept of nothingness. Okay, so this is for a ratio scale of measurement. What are the variables that we use this ratio scale of measurement for? For example, height, weight, age, marks. Okay, these are all that we have in ratio scale of measurement. Okay, ratio. Now to summarize what ratio scale of measurement is, it is basically numerical values that can be added, subtracted. This was the same for interval scale, but in addition to that, what we have now, what is the difference? What different do we have? Different thing we have now. These values can be multiplied or divided, and what does that mean? It means that the ratio comparison is now possible. Okay, it is now meaningful, right? So that was for ratio scale. So this is basically a summary of this section. Okay, so if we have just named categories, we are just naming the categories, the scale of measurement that we will use is going to be nominal scale of measurement. Okay, for example, what examples do we have in nominal scale? We have names. We have, this is just a label on a person, right? A label of a person, the name. Then we have blood group, right? So this is just a nominal scale, right? We'll use for this is nominal scale. So basically these two are for categorical variables and these two are for numeric, right? So now moving on to ordinal scale. Ordinal scale is again for categorical data, right? But in this case, what we do have the names, right? But now there is a logical sense of ordering in the categories. Okay, so what it is ranking. For example, ranking, we had that good, excellent and poor. Okay, or rating for that matter. So it all lies in ordinal scale. Okay, now moving ahead to an interval scale. These two are now for numeric. These were just for categorical data, right? This is for numerical data. Now, the first scale of measurement that we have there is interval scale. So what happens is basically the absolute zero does not exist. Like difference, we can take difference like just I just showed you 40 degrees Celsius minus 20 degrees Celsius. We get 20 degrees Celsius, and that does mean that difference in temperatures is 40 and 20 degrees Celsius. But we cannot take like ratios. We cannot say 40 degrees divided by 20 degrees means that it's twice as hot. Okay, so GPA is also in this, and grade point assessment, that is also in this interval scale. Now moving on to the last scale, that is for numerical variable, numerical data, that is the ratio scale. Okay, what now ratio scale has? It has all the properties that were in interval scale, right? Difference exists. It is used for numerical data. We can add or subtract two values. Okay, and after that, now what the difference is? The difference basically is that true zero exists, and because of that ratios are possible. Now what does true zero mean? As I explained, what true zero is basically is that it coincides with the concept of nothingness. Okay, so that is all for these four scales of measurement. So now moving ahead, just a moment. Okay, moving ahead. Now we have frequency distributions, and then we'll have relative frequency distributions. But to know relative frequency distributions, we must know this term, what frequency is. What is frequency basically? Okay, frequency is nothing but the count. Okay, what it is just count. You don't have to like mug up your head on this. What is frequency? It is basically count of a category or count of whatever we are concerned is, that would be the frequency of that thing. Okay, now getting ahead, a frequency distribution of a qualitative data. What is, for example, if we have a qualitative data, first we look at qualitative data, and then we will move ahead to quantitative data. Okay, so a frequency distribution of qualitative data is basically listing of all the distinct value and their frequencies. Frequencies is basically count. So what we do in frequency distribution, for example, we have this X, Y, Z, and we'll list their frequencies. For example, if this was twice, X was there 2 times, then the frequency is 2, Y is there 3 times, this is 4 times. So basically, and this is the frequency distribution. Now, this is for the qualitative data. Right now, we are considering just the case of qualitative data. We are just listing the distinct values, for example, X is Y and Z, and we are listing their frequencies, their counts, how many times that is occur, how many times it is there in the data set. Okay, now each row of a frequency table lists the category along with the number of cases in this category, right? For example, I just mentioned this case. Let us assume X, Y, and Z. These are our cases, okay? And this is our frequency. So this is one row, this is the second row, and this is the third row. Okay, so this is our frequency listing, right? So frequency, what is frequency? In distinct values, and what in this frequency distribution, there is just each data, there is a category, and along with the category, there is the number of cases. Number of cases means the count. For example, we have a data like this: X, 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 Y, Y, then we have Z. Okay, so how many times did this X occur? 1, 2, 3, right? So its frequency is going to be 3. Frequency is the count. Now Y, 1, 2. Okay, so it will have the frequency count of 1. Okay, now what we see is that each row, this is one row, what does it have? It has one category, right? And along with the category, it has the number of cases. Like we saw, there were 3. Each row has a category and number of cases of this category, right? So this is basically just a frequency distribution. Now, for example, we have been given a data. This is the data that we have been given. Construct a frequency table for the given data. We have A 2 times, A once, twice, thrice, 4 times, right? B is once, twice, C is again twice, and D is twice. Now we have to construct a frequency table. We have to construct a frequency table for the same, right? So what we will do is, there are basically, this is the step, these are the steps that you have to follow while constructing a frequency distribution. Okay, the first step would be list the distinct values of the observations in the data set in the first column of the table. Okay, for example, when we had A, B, C, D. So in the first column, what we'll do is like A, B, C, D. So this will be, and these are our categories, right? A, B, and C, D. But this is our first column. Okay, for each observation. Now these A, B, C, and D, these are our observations, right? What we'll do is we'll place a tally mark. Okay, tally mark. What is tally mark? It's just basically we are keeping a pictorial count of the frequencies. Okay, pictorial count of these categories. Okay, count. Now in the third step, what we will do is we'll count the tallies for each distinct value and record the totals in the third column. So total. I'll just move it to this side of screen. So what this total is, this is basically frequency. Okay, so if we have data, this is our data A, B, C, A. This is our data A, B, C, A, B, C, A, B, C, A, comma, D, A, B, B, and C. Okay, this is the data we have. Now we'll put a tally mark. Like we'll go through the data, and whenever we see A, we'll just put a tally mark. We encountered A at the first place, so put a tally mark. Now we are moving ahead. We saw A again. Okay, so again we have a tally mark 2. Now we went ahead. We see a B, so tally mark in this column. Now we go ahead. We see C, so there's again a tally mark. Now A again, so 3. Now we have D. There wasn't any tally mark for D until now, but now there is another one. Like we have D. Then moving on to A, we got 4. Then we have for B, right? Then for D, and then for C, right? So what we do is we'll just calculate total. What is total? This is the tally marks. How many tally marks are there? 1, 2, 3, 4. Okay, so the frequency of A is 4. B, 2. C, 2 again. And for D, we have again a tally mark of 2. So this is how we construct a frequency distribution. Similarly, this is like this proper table. What we have done is basically the same thing that we did above. Okay. In this case, let me get the, for example, if we have category A, okay, we saw it in the first place. Okay. Second place also B. Okay, we saw it for the first time. We are here. Now we saw C. Okay, this is done. Now we saw an A. So again, we come to A. Now a D. We go back to D. Now to A, again A. Okay. Now we go to next observation, that is B. So we'll just increase the tally. After that to the D. If C, we'll again increase the tally, and then C. Okay. So what is the frequency? It's just the total of these tally marks. What is that? 4, 2, 2, and 2. What is the total? 4 plus 2, 6 plus 2, 8 plus 2, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we do get the total observations are 10, right? In fact, from this frequency, when we sum up these frequency, it would be equal to that frequency session. Okay, frequency. Okay, now moving on to another listing of data. For example, we'll have A. We'll just go there, A, then again A, right? We'll just keep increasing on the tally mark. We have dealt with this. Now we'll go to B. Okay, B is there, C is there, A is there again. Then we have D, the D is again there. Then we have A again. Okay, so we are just listing it out. Then we have B. Okay, B is there, B again, and C. Okay, this is there. Then we go to A. So we'll just cross it off. This means 5, the fifth one. Okay. After that, what we'll do is we'll just move ahead to another one, that is B. Okay, just go there. C, this is there. Then we'll go to D. Okay, so D is there. Now A, we have done this, 5 are there. So this will represent the 6th count. So what we have, 1, 2, 3, 4, 5, 6, 6 for this, 3 for this, 3 for this, and 3 for this. Okay, so this is our frequency. This is our frequency distribution of this category, this data. Okay, similarly we can make for this data as well, right? So that we can do. So now coming on to the concept of relative frequencies. Okay, just a moment. So what is relative frequency? Now we have understood what frequency is. Okay, now what is relative frequency? Relative means, as the word suggests, in relation to something else. Okay, so what is relative frequency? Like when we got to frequency, we just saw what is frequency is. Frequency is basically count. Now what is the relative frequency or relative count? So what it is just basically the ratio of the frequency to the total number of observations is called the relative frequency, right? For example, in this, okay, we had total 10 observations. Okay, so the frequency of A was 4. Okay, so what will be its relative frequency? It will be 4 divided by the total number of observations. That will be 4 by 10. For 2, it will be 2 over 10. For a C, it will be again 2 over 10. That is the total, the frequency of the category divided by the total. Then D, this is again going to be 10. Okay, so this is what we have for these are the relative frequencies. Okay, relative frequencies. Okay, and this is going to be equal to 0.4. This will be equal to 0.2. This is again going to be equal to 0.1. This is going to be again equal to 0.2. Okay, now there is one interesting thing to notice here. If we take the summation of these relative frequencies, summation of relative frequencies, basically what this symbol represents is sum over everything. Okay, summation of relative frequencies it is equal to 1. Okay, so we can confirm that from here. 0.4 plus 0.2 equals 0.6 plus 2, 0.8. 0.8 plus 2, that will be equal to 1. So this is the key thing to note here. Summation of all relative frequencies is always going to be equal to 1. Okay, so this was for relative frequencies. So how do we get relative frequency? Formally, how do we get it? We'll first obtain a frequency distribution of the data, right? Because it is relative frequency. Though first we have to calculate the frequency. Okay, and after that, what we will do is we will divide each frequency that we got in the frequency distribution divided by the total number of observations. Okay, so that will give us the relative frequency of each category or of each value. Okay, so this was for frequency relative frequencies. Okay, let us go to this example. Okay, this was the 4. What is the total? 10. This is just the example that I did above. So its relative frequency would be 4 divided by 10. For this, it would be 2 over 10. For this, again, it is going to be 2 over 10. And again, it would be equal to 2 over 10. So it will be 0.4, 0.2, 0.2, and again 0.2. So the total of relative frequencies will be 1. Okay, and the total of when we have frequencies, when we take the total of frequencies, we get the total number of cases or observations that we have, right? But when we take the total of relative frequencies, the summation of relative frequencies, what we get is 1 basically. Okay, so this was for relative frequencies. Now, why do we need relative frequencies? So basically, if summation of sum of all, for example, if we have four values, A, B, C, D, right? A, B, C, and D. Okay. So there A, B, C, D, B, A, B. So these all will have their relative frequencies. Let relative frequency of R B A, RA plus RB. And then for B, for C, it would be RC plus RD. Now from relative frequency, we just saw it was always going to be equal to 1. Now, since this is addition and relative frequencies is positive, what we can conclude from here is relative frequency of a particular category for is always less than or equal to 1. Okay, it is always less than or equal to 1, right? So when will it be equal to 1? When all the observations are the same, right? If we have A. In this case, what is the frequency of A when we make the frequency distribution? Okay, A, its frequency, it is going to be 1, 1, 2, 3, 4, 5, 6, 7, right? So total, how many observations we have? 7, right? So what its relative frequency will be? That would be 7 by total. Okay, so total in this case, that is again 7 by 7, so that will be equal to 1. So what we can conclude from this is that relative frequency is always less than or equal to 1. Okay, so this is for relative frequency. Okay, now moving ahead, this is just the table that we just constructed for relative frequency. So what was the summary of the section that we just finished? So what we saw is first how we construct a frequency table, right? Frequency, like we list the tally marks and we just count them and we see how these frequency listing is done. Okay, then we moved ahead and we saw the notion of relative frequencies, and then we saw how we construct a relative frequency table from the given frequency table. Okay, from the frequency table, how we construct the relative frequency table. Okay, this is for this section. Now moving on to charts. So what basically charts are? Okay, now when we have data, like we can either represent it graphically, right? When we are concerned with representation of data, what we can do is we can represent the data graphically, or what we can do is we can represent it numerically, right? Like some numerical measures that we'll use for that. So first, let us look at how we graphically represent the data, how we present it, okay, for better understanding or for whatever purpose we need to present it for, like presentation. Okay, so the first thing is we'll just first deal with categorical variable. Okay, so we'll just deal with graphical representation of categorical variables. Okay, so what we have is like there are two charts are basically graphical representations. Okay, these are just graphical representations. And basically graphical representations of the data. Okay, so the two most common displays is graphical representation, or what we call as display. So the two most common displays of a categorical variable, and that we have studied and that we will study in this course, are bar chart and pie chart. Okay, what do they both? They both describe a categorical variable by describing its frequency table. So we had frequencies. So what we will be doing in both bar chart and pie chart, we will be displaying the frequencies or relative frequencies of the variables. Okay, we will just display those and graphically. Now up till now we were like just displaying them in form of a table, right? Now what we will do is we'll just display them graphically, okay, in form of charts. So let's get ahead. So first let's go to pie chart. Okay. So when we hear the word pie, we basically are taken to a circle, right? When we had this in circle, we have that the radius is pi. Sorry, the area is pi r square, and the perimeter is 2 pi r, right? So basically, pi it's just somehow it connects to a circle, right? So what is a pie chart? We just get there. A pie chart is basically a circle. It's just a circle like this. Okay. So what do we do to this circle? Why is it called pie chart? Further, it is a circle. First of all, it is a circle. What we do is we divide the circle into pieces. Okay, we'll just divide it into pieces like this. We'll have pieces like this. Okay, now what these pieces, how do we divide the circle into pieces? We divide it into pieces proportional to the relative frequencies or frequencies of the qualitative data. Okay, so basically if data has if we have a data, for example, we have a large data in that, if some category occurs like a lot of times, so what we mean to say by pieces proportional to the relative frequencies is that basically the category that has more count, whose frequency is more, it will share it on the pie chart, its share will be like bigger. It will have a bigger area share in terms of area on the pie chart. Okay, so in this case we can say, for example, this is A, so we can conclude that the relative frequency of A is the most in the data. Okay, so that is basically what we can conclude from this pie chart. Okay, so now how do we construct this pie chart? So what we do is, in the pie chart, what we do is we just take the circle, right? This circle is divided into pieces proportional to the relative frequencies, like I just said. So what we do is basically we'll just distribute frequency distribution or relative frequency distribution that we had. We'll first obtain that. For example, these are the categories. Okay, these are categories, and then what we have is those frequencies or relative frequencies or relative frequencies. So what we will do is we will divide this, like we will have some values 0 0.4, 0 0.2, 0 0.1, 0.3, right? So what we will do is, for example, these are the values that we have. We will divide the circle in pieces proportional to the relative frequency. For example, the relative frequency for, let's say this was category A, this was category B, this was category C, and this was D. So since we can clearly from the data, the frequency for, or relative frequency in this case for A is the most, right? So we will, when we will divide the circle into pieces, we will divide in such a way that the category A has like the most share in terms of area on the pie chart. Okay, and the least in this case we can see it would be C, because it has the least frequency, relative frequency. The most is A, and for B and C it will lie in between, right? A will have the most share or in terms of area on the pie chart. Okay, now after that, for example, this is what we got. Okay, let me just say this is what we got. This was for A. This is for let's say this is what we got. This is what we got. A, B, C. This is what we got. Okay, for example, you can see this is A. This got the most share. Then we can see, then it's D, then it's B, and this is 1. So what we have, this is C. Okay, now what we have done in this case is we have divided the circle in such a way that the area of each category on the circle, it is proportional to its relative frequency. See, we can see the relative frequency of A is the most, so its share on the pie chart would be most. Similarly, after that, B has the highest relative frequency. So after A, the highest share on the chart would be for B, and B has less than that, so it will be B. And C has a little less, least. That is, we can see. So it will have the least share in terms of area on the pie chart. Okay. So how we, like, now we know that the circle, there are 360 degrees, right? When we draw the circle, this is 360 degrees, correct? So how do we know what is the share of this, like each, what angle, if we want to be precise in terms of making the pie chart? Now we need to know, like when we have, for example, a category like this makes an angle here, right? Now we want to know this angle is basically proportional to its relative frequency. For example, this was less. We can conclude like this angle is less than this, right? From this, we can conclude that this has like more relative frequency, right? More. It's less, right? Now these angles, if we want to be precise and we want to like construct a precise pie chart, what we do, we want to know these angles, because these angles are going to be in the representatives of the relative frequencies, right? So what we'll do is we'll just, because there are 360 degrees in a circle, right? It extends 360 degrees. So what we will do is we will just, this is the relative frequency, and we'll multiply it by 360, and we will get the angle of that category on the pie chart. Okay, for example, in this case, let me go here. For example, 0.4, we'll just multiply it by 360, okay, to get its angle on this pie chart, right? This is just in case you need to be exact and precise. You'll just multiply it by 360. This will also be multiplied by 360. This will also be multiplied by 360, and this will also be multiplied by 360. So from this, you can clearly see that let me change the marker color. So you can clearly see that this is going to be the most, right? 0.4 into 360. So the angle subtended by this category A, it will be the largest. And we can see the angle subtended by C, it is going to be the least, because the multiplication factor 0.1, it is least among that. This is constant throughout 360, but then 0.1 is the least. So when we multiply it by that, it will be the least angle, right? So what we get is we will get the angle corresponding to C, and that will be least, and that will like the area of category C is going to be proportional to its relative frequency in that sense. Okay, so basically this is how it's done. For example, in this case, relative frequency 0.4 into 360, 144. This is going to be 72, because they all are 0.2, so they will be 72, 72, 72, and at the end it should be equal to, like, we should be getting the entire circle, right? So this all has to be equal to all the angles that have been subtended by these categories. It has to be equal to 360. Okay, so this is how we basically construct a pie chart. So now what we have dealt with in this section is basically we saw what a pie chart is. It is basically a chart that a graphical representation of categorical data that shows the proportion of a categorical variable, right? It just shows the proportion. If we have on a circle, it just shows the proportion of one data variable, right? Now if we have a categorical variable, right? If we have a category like if we have a category like this, okay, if you have categories like this, okay, this is one category, right? The one A, B, C, like let us assume we have three categories, A, B, and C. Now what we can do is, for example, in this case, we can see that A clearly makes up more than half of the data set, right? Or the total A makes more than the half, because half is this, we can see from there, this is half, and A is clearly extended those limits, right? So what we can say is, from this pie chart, it is clear, like if sometimes we have a data value that takes up more than half, we can clearly see that it makes up more than half of the total. This is a good way to show that when we have to show if a data value and just a moment. So it is a good way to show if pie chart, like if a category makes up more than half of the total. Okay, so now moving on to the second display, the second graphical representation that we have for the categorical variable. So this is bar chart. This is the second one. The first one was pie chart, and the second is bar chart. So basically bar, like when we hear the word bar, this is what we think of intuitively. What we think of is bars, right? So this is what we have in bar chart. If like the intuition does coincide with what we think, what the bar chart actually is. So this is our bars, these are bars. So basically what we do in bar charts is we construct these bars. Okay, and what these bars are, these are just proportional to the frequencies, the height of the bar. For example, I can make a bar of this height, right? I can make a bar of this height as well, right? So what is differentiating this bar from that bar? Like obviously the height, but what is the height proportional to? So in this case, in pie chart, the angles or the area a category had on the pie chart that was corresponding to its relative frequencies. In this case, the heights that we have for the bars, like in the pie chart, we had each, for example, if it was there this way, if it was there. So each slice, these slices, these are just like pizza slices, right? Each slice represented a category. So in this bar chart, what we have, each bar represents a category, right? For example, if we had A, B, C, D, then it would be A, B, then so on. We can just construct, okay? So what, like I'll just read out the formal definition, what it is. A bar chart displays those distinct values of qualitative data on an horizontal axis. Horizontal is basically this one, right? So on this axis, what it represents is like this. For example, here we are just listing the categories, right? This is a horizontal axis, right? On this axis, we are just listing the categories, right? Listing the categories. You can do it on this side also, but then it will be like this, right? We are just listing the categories. And on this, what we are doing on the y-axis or on the vertical line, what we are doing is we are plotting these bars. We are making these bars proportional to the relative frequencies of these categories, right? If we were to do this in the opposite way, what we would do is like basically we do this with this, sorry. These are the categories we would have. For example, this is A, this is B, and we have relative frequencies on this side, okay? So relative frequencies would have some value. So what we would do is basically we would construct the bars in this manner, okay? And in this manner. And in this case, the values on this vertical axis will correspond to their relative frequencies, okay? One thing that we have to be careful of while making these bar charts is that these bar charts should not be touching each other, okay? Because these are two different categories, right? A is different when B is different. So we don't want those overlapping of bars. So what we do is basically we just put a little space in those and we move on to make the next category, okay? Now let's see what are the steps to construct a bar chart. So what we will do in bar chart is basically first, like what we did in pie chart was we obtained the frequency or frequency distribution or relative frequency distribution of the data, right? We will like made this was the table. These were categories. We had categories here, categories. There were relative frequencies for like A, B, C. Like this was, let us say this is A, this it has relative frequency, this is B, this is C. So we'll first do this because we need what we are representing in the bar chart or pie chart is the frequencies, right? We are just comparing them now, like on seeing the pieces, the height of bars, we are comparing these relative frequencies. Okay, so basically we need to deal with the relative frequencies first. So first step would be to obtain the frequency or relative frequency distribution of the data. Okay. Now once we have done that, now what we will do is draw a horizontal axis. Okay, I'm doing it here. So on a horizontal axis, now what we use this horizontal axis is basically we can use it for either the category. I'm just going ahead to use it for categories. Okay, so I just put on the categories here, right? So we had categories A, we had B, we had C, we had D, and there should be no overlapping because these are different categories, right? So what we'll do now is we'll construct a vertical bar, okay, that will correspond to, that is going to correspond to the frequencies or the relative frequencies that we are interested in summarizing graphically, okay? So we'll construct this, and on this vertical axis, we'll have frequencies or relative frequencies, right? So this is what we'll do. After that, what we will do is we will construct these bar charts. For example, this is 0.4, 0.2. If it is relative frequency, the maximum is always going to be 1, right? So we are certain that it will lie below 1. So what we will do is basically we will construct bars, literally bars. So what we do is we construct bars, and what the height of these bars will correspond to the frequency or relative frequency of the category. Okay, so basically what we are doing here is, like, we can see we are comparing the relative frequency. It is a like nice measure. We can visually just compare the relative frequencies from this graph. If you have a bar chart like this, you can just come up with the thing that B has the highest relative frequency, right? We can say, for example, if these two are equal, we'll say A and B have the equal relative frequency and C has the least relative frequency, right? So basically what we are doing is we are just graphically we are displaying these relative frequencies, and it just makes it easier for us to comprehend like how the data set is. Here we can see the data set is such that the B has the highest relative frequency, which means that B must occur like the most time the B must occur in the data set, right? C has the least relative frequency, which would imply that C must occur the least number of times in the data set. A and B have the equal relative frequencies, which would necessarily imply that these occur equal number of times in the data. Okay, so this is done with bar chart. This is how we basically construct a bar chart. Now we have Pareto charts. Okay, what is a Pareto chart? Basically, it's nothing to be afraid of. It's just a bar chart. Okay, it's basically a bar chart. Now, what is the difference? If it is a bar chart, now what is the difference? So, like, we use bar charts and these pie charts for categorical variables, right? Now, in categorical variables, we saw that the variable could either be like the scale of measurement could be nominal or ordinal, right? So, if we have to represent an ordinal variable, like if a variable follows the ordinal scale of measurement, and if we have to follow that up, we have to draw its display, its graphical display, then we will go with Pareto charts. Basically, it is a bar chart that is ordered bar chart in which we show the order. Okay, in Qualifier, okay, so basically these are very famous in like, and mostly they are used in business processes, because we want to see like the order, we want to maintain the order. So that is why we use Pareto charts. So basically Pareto charts is like, it is a categorical, basically it is a chart for categorical variable. But when the categorical variable is, when it is ordinal, we will use Pareto charts. Okay, then the bar chart must be preserved. Like when it is ordinal, so there is that sense of ordering, right? So when presenting it graphically, when displaying it graphically, we need to preserve that sense of ordering, right? Else how would we know like if it is nominal or ordinal? So in order to preserve that, sense of ordering, that logical sense of ordering, what we do is we make Pareto charts. It is basically a bar chart that is ordered. Okay, there is nothing more to it. So basically we'll see an Pareto chart here. Okay. Pareto chart, just let me have, I was there. So basically the relative frequency is 0.26, 0.240, 0.20, 0.14. So we'll just maintain the order, right? This is relative frequency. If it is least, then you can go for most. Then it is like this, and it's like this, in the sense that order is being maintained in respect to the relative frequencies. Or it can go the other way, like you can have this, the decreasing order. But in this sense, but in both the cases, we are maintaining that ordering, the logical ordering of the variable, right? So this is what we use basically, use Pareto chart for. Okay. So t-shirt size is basically, that is an ordinal, because basically it is just a name, a nominal. It is naming of different sizes, and it has a logical ordering, right? Like small, medium, large. You can sense that there is some logical ordering there. So in this case, if we have to construct a bar chart, it would be a Pareto chart. Okay. So for here, what we will do is, and just let me construct, since like the ordering is small is less than, like you can sense that small is less than, a medium is less than large, correct? So we'll just have like, this is for small, this is medium, this is large. The ordering, the sense of ordering is preserved. For example, this is 0.35, as it has been mentioned. This is 0.35 as it has been mentioned. For medium, it would be 0.40, a little more. And for this, it is going to be 0.25. So the relative frequencies are like different in this case, but the ordering is maintained. Like the ordering that we had, it is preserved. You can go the other way. You can put large first, medium will still be in the middle, and small at the last. But the sense of ordering that we had, the logical sense of ordering that we can sense, it is maintained. So this would be our Pareto chart. Okay. So now summing up this section, what we did is we first studied like the graph. We first saw like we can represent the data we had, categorical variable in graphical. Graphically, we can express it. So we had two expresses, like we had two displays for categorical variable. One was bar chart and the other was pie chart, right? So in bar chart, in pie chart, what we basically did is like we draw a circle, and in that circle what we do is we make slices, and slices for each category, and the slices are basically proportional to the frequencies of the categories, right? If a category has more frequency, then its slice will be wider. It will take more space on that pie chart. And then we moved ahead to a bar chart. Bar chart was basically we were making bars, and the height of bars, it was, and the height of the bars was, it was corresponding to the relative frequencies of each categories, correct? So this is what we have done in this section. Now let's move ahead. Now when do we know, when do we use bar chart and when do we use pie chart? Okay, so basically we can use bar chart and pie chart. It has to make sense. Now when should we go for bar chart and when should we go for pie chart, right? So we need to know that. So basically pie charts are best to use when you are trying to compare parts of a whole. Okay, if we have one category and we are if we have one thing, entity, and we want to compare the parts of this. Okay, for example, if we have a person and his marks, the person is the same, his marks are total. If we want to see his marks, like what share of marks is from one particular subject, these are the parts of whole, his total marks. These marks of individual subjects, these are parts of that whole like marks. So in that case, pie chart is the best thing to do. Pie chart is the best graphical summary that we can use. Okay. Now, when should we use bar charts? Bar charts are basically, these are best to use when we are comparing between different groups. Okay, if you are comparing between different students of the same class, marks of different students of class, then we can go for bar chart, because now the categories are different, the groups are different. So we need to compare between those, right? Now in this case, bar chart will be a better display to use. Okay, so that is for we need to know what our purpose is and how, when do we have to construct a bar chart and when do we need to construct a pie chart. Okay, so now another important thing, like when we are using these graphical summaries, when we are using these displays, there are a few practices that we need to follow, and we need to avoid some of the practices so that the graph is it is a good representative of whatever we want it to be. Okay, so first thing first, we want that we should label the data, right? If this was our pie chart, okay, and these were our slices. Okay, now if we didn't label these slices, how can we comprehend what slice corresponds to which category? We cannot. From this we cannot. We can just say, okay, this slice might have with this slice might have the most area, so it might be the most occurring. But can we know which category this belongs to, which category this pie chart represents to? No, because it has not been mentioned. So what we have to do is we have to mention this is for category A, category B, category C, right? So this is a practice that we need to follow. We need to label our charts, we need to label our bar chart, we need to label our pie chart. In the pie chart, we need to label these slices. In the bar chart, the slices that we make, right? There we were making those bars, right? The bars, we need to mention this is for A, this is for B. Okay, this we have to mention, because else if someone else is looking at the data, you might yourself know, because since if you have constructed the data, For some time you might remember what this was, which category it represented, but other person looking at it, he or she, they cannot comprehend which category this corresponds to, right? So basically we need to label our data. Okay, so basically first thing, label. Okay, name the bars, name the slices, and the last part is if we have omitted some of the cases. Now if we have omitted some of the cases, like sometimes there are some cases that are not important, right? These are like least consideration, we don't need to consider these much. Now what we need to do, what we need to make sure is the that the plot defines that the collection that is summarized. For example, if we had this data, we need to summarize. For example, there were other significant categories. If there are a large number of categories in this data, if we had like categories A to Z, and we were basically concerned with the first three categories, A, B, C. So we'll just say, for example, this is A, this is B, and this is C. Let me take it down. Okay, this is A, B, and C. Okay, now this is A, this is B, and this is C. Now we are missing out on the other categories that were there, right? So we should if you are not, these are those significant categories, we needed to study these three. Like we can do another graph and like mention others, right? This needs to be there. Okay, so basically this is what we have to do. Okay, moving ahead, basically this is the labeling of data. Like we have to label, and we have to show how much it's also like the share of this. Like for example, there might be a case like this. If we have these cases like this, let me just draw it like this. Okay, this might seem a little equal to somebody, might say these are equal, but in the sense really they aren't equal. So if it is 29%, suppose this is 29, this is 31. In large businesses, 2% can make a lot of differences, right? So we need to mention like how much this is. We cannot just mention this is A, B, and C. Yeah, we can do that. Like in this sense, what we are getting is we are just getting the sense like C has the most, but we cannot exactly make like what about A and B. What is their like relative frequencies? What is the share on the bar chart? But the moment I say 29% and 31%, you can be sure, oh, this is 2% more or that is 2% less. So basically we need to do this. This is a good practice that we have to label our data, not just the name, the category, but the share of this category. Okay. So for example, this was for this we have done for pie chart. Now moving on to bar chart. Now in bar chart, what we need to label is our slices, right? These are bars. These are the bars, right? These are slices. Okay, we need to mention which category these belongs to. Like this has been mentioned A, B, C, D. If it wasn't mentioned, I could never make sense. Like I could just guess this is A, this is B, but I could never make sense of which category is which, right? And this is the frequency that has been like mentioned. This we need to mention. Okay, basically here we can see that these are equidistant, right? So we are saying, yeah, there must be midpoint 1, there must be 3, 4, 5, then 6, then there must be 7. So we can, but sometimes it may not be the case, right? These might not be equidistant. So in that case, we need to make sure that these values are mentioned. Okay. So this is for labeling our data. So now this is for the many categories case that I was talking about earlier. So for example, if we are concerned, like we want to study these 4 categories in much more detail, right? These are more significant categories, more significant. Let me put it that way. These are more significant categories, okay? These are a little more significant than these. These aren't that significant. So what we'll do is basically now this is just like we want to study these categories, and these are just the categories, these are less significant, but it just takes that, like if it was like this, the data would have looked nice and it would have preserved the essence that we wanted to study, that is the most significant categories. So in this case, what we can do is from the categories from like say these categories from E to Z, these are less significant. What we can do is we can club them together in the category and name that others, right? So basically we can do that. The bar chart or pie chart with too many categories might conceal the more important categories, right? The categories that we are here concerned with, the more significant categories. So what we'll do is we'll just group these others as other, and the other that are less significant as others, right? So this is how we can do it. Like A, B, C, and D, like these are the categories that we are like more significant, that we want to study in much more detail. Now these aren't those significant categories. We don't like we don't want to study them in much detail. So we have just clubbed them in other categories. The category we have made a separate category for that. Others. Okay, just drink some water. Now moving on to another practice that we need to follow while making these charts, these displays, is the area principle. Displays of data must obey a fundamental rule. There is a fundamental rule, like whenever we are displaying a categorical variable, its frequencies or relative frequencies, whenever we are displaying those, what it must do is it must obey a fundamental rule. There is a fundamental rule that is called the area principle. As the name suggests, it has something to do with areas, right? So what it basically is, what is the area principle? The area principle basically states that the area occupied by, for example, the area occupied by the slice on the pie chart or the height of the bar chart, it must correspond to the amount that it represents. What it means is basically it must correspond to the relative frequency that is it represents, right? For example, let us say we have three categories. These are our three categories. Okay, so if we can see clearly this, make this 4. We have 4 categories. For example, this is A. No, let us say here A. This is A. Let us say the frequency of A is 0.6. Frequency of B is like less or whatever. Now, if we say this is A, does it serve justice to A? No, it doesn't. Why? Because we can see clearly that this slice, this occupies the most area, and like we know A has the most frequency. So this slice should be for A, right? So we need to make sure that the category which has like the slice on this, in this case the slice on the pie chart, it must correspond to the amount, the relative frequency that it represents, right? If it is most, like it should be indicative of that. Yeah, this is the most. If, for example, if C is the least, 0.1, it should be here C. It should not be in place of A, because then A should not be in place of C and C should not be in place of A, because then it does not corresponding to the relative frequencies, the areas that it is corresponding to, right? It does not show those, it does not justify in the relative frequencies on these graphs in terms of area occupied, right? So this is basically the area principle. Okay, the graphs need to follow these area principle. Okay, so now what happens if we don't follow the area principle? Like I just said, if this is for example C is 0.1, if we say C is this, A is this, if somebody doesn't know this, if for example you don't know this one, this is hidden from you, what you will conclude, basically you will say that C has the highest frequency, right? Because it is occupying most area on the pie chart. Okay, and A will have the least frequency. But is that the case? No, the case is that A has the most frequency while C has the least frequency. Though this graph is misleading us, right? This is misleading us in the direction that C has the most frequency, so it is corresponding to the most area, and A has the least frequency, relative frequency, therefore it is corresponding to the least area. But that is not the case, so it is misleading us. So what we need to do is we need to obey the area principle and show which category has the most frequency needs to be the category that has the highest area on the pie chart. Okay, now moving ahead, there are some like other violations that happen, that are misleading graphs. Basically you see there are some decorated graphs. These are basically charts like they just want to attract attention, they want to get attention. Like if we have a fancy chart, these are fancy charts to be like, let's call them fancy charts. What they are basically, they are not like they're there for study. You're not interested in me, like they will show For example, if you go to a marketplace, there would be a fancy chart that would be showing at 8, 8, 8, 8, 8, 8. Yeah. Okay, you give the key to the server. I'll do it myself. Oh. Thank you. So basically, what I was saying is these decorated graphs, these fancy graphs, they are just there to like attract the attention of the people. They're not there for like the studies purpose, the analysis purpose. So these are misleading. Okay. So for example, there's this one. You can see, you don't know. They have mentioned that, for example, they're 153.3, 150.3. So they haven't mentioned like what is the baseline, from where is it starting? Are you starting from 0? Are you starting from what? See, you can't see even the Italy one. You can't see it. Japan, these are like their area isn't the same. What is this? This is just basically a fancy graph of showing the wine exports. So basically here, it is just like decorated, no baseline. So you can see that, and the shapes and sizes are different. So you can see that this is wider, this is not as wide. We can't even see where Italy lies. Japan and Netherlands has different size. So basically, this is a misleading graph because we don't know where the baseline is. The area principle, the the bars are of different size. So we should like these are examples of few misleading graphs. So now, what if we had to we'd have to make a good graph out of this, not a misleading one? This would be the better way to do it, right? Like we are starting, the baseline is there, area principle is obeyed, the bars have the equal width. So this obeys the area principle, and it is also accurate. So this, instead of this would be a better and is the better representation of the data. Okay. Now, moving on to another misleading graphs, that is truncated graphs. What is truncated graphs? Basically, when if we have a graph like this, okay, I'll say that this is 45. So what we assume, basically intuitively, what we assume is this has to be starting from 0, right? And this is 45 then. But what if it doesn't start from 0? It started from 25. You said that we said that the height is 45. But in this case, it is only 20, right? So what happens in this case? We call such graphs as truncated graphs. The graphs where the baseline does not start at 0. Like we can see here, the baseline starts at 75. This is also a misleading graph. Like, for example, if someone would just look at it over, we can say, okay, 146. But this is from 75. This is not starting from 0. The count has started from 75, right? And it has ended at 146. But is this like, are there 146 counts? Can we say that? No, because this hasn't started from 0. This has started from 75. So what we need to do is we need to avoid this. Or if sometimes like we had counts in tens of thousands, in that case, we need to maintain, like we can either change this scales of these whatever in the counts we can change, or what we can do is we can just indicate that we are not starting from 0. Like this is basically exaggerating. This is exaggerating, right? This is exaggerating. When you look at this, you would say, okay, so 100 count is 146. Okay, you will comprehend, okay, it is 146. But it would be 146 when it had started from 0, right? 0 to 146, then there are 146 units. But did it start from 0, right? No, it didn't start from 0. It started from 75. So it is not equal to 146. So it is misleading us, right? We can see that this category has more count than this category. The category S has more count than category W. But the thing is, like, is it representative of the data, actual data that it is representing? Like here we concluded is 146, but it's not the case. Like, but in this case, in the other case, it's starting from 0. And if it is going to 146, yeah, we are sure that this is 146, right? But the baseline is at 0. So what we need to now, if sometimes we have to make this, like we want to show the baseline is not at 0, because sometimes we need to show. There might be cases where we want to, like, there are a lot of counts and we don't want to start from 0. It would be like the height would be too much, right? So what we will do is we'll just indicate a graph break, y-axis break in this way, right? And what is this k? This k represents, for example, represents what baseline is, where the baseline is starting, what baseline is, right? In the previous case, for example, it was 75, so we would say 75. Now whoever knows statistics and knows this is truncated graph, what he will say is, okay, so I have to comprehend it in the sense that the graph is, the baseline is starting from 75, not from 0. So this is the way you indicate a y-axis break. Okay. No, now there is another error, round off error. For example, if you are, this is your pie chart, okay, you are just rounding off the, for example, it is 29.33, it is 30.89, this is 40.77. Now what you are doing is you're just saying, okay, this is 29.32, let me just round it off to 29.29, okay, then to a whole number, this is 40.77, I'll just round it off to say 41, okay. This is 30.89, I'll just round it off to 31. Okay, so what it is doing is, when you take the total, earlier the total when you would do it would be 100%, right? But since now you are rounded it off, you have increased 1 unit here, you have increased some units here, it won't be equal to 100%, right? It won't be equal to what the whole. So it is very important to check for round off errors, like are they adding up to 100? If not, then there is some round of error. Okay, so this was for round of errors. It is very important to like check for the round of errors. This is what we have done in this section. So let's move ahead to summarizing the categorical data. Okay, so now I just told you, like, we can summarize the data either graphically or numerically, right? We are talking about categorical data. So graphically we have looked how we summarize the data graphically. Now let's move ahead to the numerical summarization of the data. So graphical summary we have done. Now we need a compact basically numerical measure. Okay, numbers. Now what are these numbers? As numerical itself, these are going to be numbers. What are these numbers used for? These are used to describe data sets. Okay, and these are called descriptive measures. These are called descriptive measures, the number that are used to describe data sets. Okay, so what these descriptive measures, those which indicate where the center is, like if we have a data which is the centermost observation of the data, or which is the observation that is most frequent. Okay, so we call these as measures of central tendency. Because now, why are they called as measures of central tendency? Because they represent a central value. For example, if we have mean, right, mean in median, if we have median is the central value of the data set, right? So these are used to represent those typical values. Typical value is basically the value which is occurring the most number of times in the data set. Okay, so that is why these are called as measures of central tendency. So for categorical variable, we have these two, mode and median. Okay, because like we saw there, arithmetic, why don't we have mean? Mean is, we saw like in categorical variable, there is no sense of like arithmetic addition and subtraction. So we don't have mean. We have only mode and median. So what is mode? Mode is basically in the category, the category which has highest frequency. The category with the highest frequency is called mode. Okay, so this is basically the definition of mode. So now how do we see the mode? Mode is basically the highest frequency. So when we were like constructing pie charts and bar charts, in bar charts we saw that the these slices are indicative of the frequency. These are corresponding to the frequencies. These are relation with the frequency. So more the frequency, more area it would cover on the pie chart, right? So more frequency means like it is occurring more relative frequency means it is occurring more number of times in the data set, right? So in pie chart, the mode will be the widest slice, the slice that is the biggest, that occupies the most area. And in bar chart, the longest bar, because the bar height of bar represents the count, right? Basically the category with the highest count is occurring the most number of times, right? So that is going to be mode. So longest bar in the bar chart and the widest slice in the pie chart is going to be the mode for, okay. So in Pareto chart, what it would be like the first category that is shown, right? Because it is going to be the most occurring category, right? Now let us see. For example, in this case, the longest bar is A. So we can say the most common category is A. Most common category by saying count. Like basically this is count. So if count of A is the most, so it is safe to say that A is the mode of the given data. Okay, in this case, we can see that 40% is the highest. So the most commonly occurring the category with the highest relative frequency is A. When it has the highest relative frequency, it means that it has occurred the most number of times. So it is going to be the mode. Now, what is bimodal data and multimodal data? Bimodal, as it says, bi means two. If in a data set there are observations that occur more than once and equal number of times and are the highest, then it is bimodal. For example, if we in this we can see, okay, A and C, they have the equal number of their frequencies, their counts are equal, right? So we can say this is a bimodal data because these have highest frequency. Okay, so this is for like mode. Now moving on to median. Median, as the name, like it is a little indicative of, median is that like basically what we median gives us is the middle value. Okay, so when it gives a middle value, it means that the data needs to be ordered in the first case, right? Only then we can make sense of like middle value. If that there it was nominal only, there was no middle, there was no like ordering, we can put any category in middle and it will be the median, right? So in this case the middle value is only like we can only find it if the data is ordered. So when we have a like order data in categorical variable is ordinal data, right? Ordinal data offers us this measure, that is median, that is the middle value of the data set. Okay, so that is median, right? The median of an ordinal variable is the category that is in the middle. So how do we find which is the like ordinal, like median? So if we have even number of observations, like if you have A, B, C, D, E, F, like we have 6 number of observations, to choose the category on the either side of the middle of the sorted list. Like if A is less than B is less than C is less than D and E and F. So we have number of observations 6. So the middle would be 6 by 2, third, fourth, either fourth or third. So that would be our median in the sense, the category on either side of the data. If they both are same, like then it's easy. But if they are different, for example, C and D, for example, then either C is the median or D is the median. Okay, this is for median. Now, if it is odd, then it will definitely go be the middle observation. Okay, if there are equal number of observations on this side and equal number of observations on this side, then this is going to be the middle observation, right? Correct. B. Then the order, like first we need to order the data, right? This is the ordered data. Then we'll see which is the middle category, and that will be our median. Okay, this is just an example. Like we'll consider this. Consider the grades of 15 students. We have been given 15 students and their grades are given like this. We know like that A is greater than B is greater than, there is that logical sense of ordering in the data. So what we'll first do is we'll order the data. Okay, we have ordered it A, B, 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 B. This is what we get. The median. Now we have gotten this order data. Now we have 15 students, so the 8th category is obviously going to be the median, right? 15 plus 1, median is 15 plus 1 by 2th observation, right? 15 plus 1 is 16 by 2, so the 8th observation. So we can see that the 8th observation is, in this case, it is 8, B. Okay, so B is our median. Okay, for the next case, if we have 14 variables, so what is 14 by 2? That is 7. 7 and 7 plus 1, that is 8. 7th or 8th observation will be our median. This is the formula for median. If it is odd, then n plus 1 by 2th observation. Okay, if it is even, it is n by 2th or n by 2 plus one's observation. Okay, so in this case, it would be if we have 14 by 2 7 and n by 2 14 by 2 7 plus 1, that is 8th observation. So we can see that the 7th and 8th observation is B. So the median for this data set is going to be B. Okay, mode median is going to be B. Now what is the mode? We can see most common grade is B. So this is our mode, right? Now what we are just trying to say here is that median and mode not need to be equal, right? In this case, median is B and mode is B, right? But in this case, like we can see, we just saw median and mode both are B. But in this case, we can see the median is B, right? But the mode is A because it's occurring the most number of time. So what we conclude from these two examples is that median and mode, they are not like equal. They don't need to be equal always. They can be different, they can be same, but it is not necessary that they have to be equal. So this is the summary of what we studied in the last section, the mode and the median of the data. So this is what we did in this section, today's revision session, and thank you. This is all for today. Okay, I'll just okay, you can unmute now. The session is over.
Hi, good evening, sir. I have just a basic question. Will we have week 3 and 4 tomorrow?
Yeah, we will be having week 3 and 4 tomorrow.
Yeah, thank you so much, sir. Thank you so much.
Okay, you're welcome.
And will you show the frequency distances and correlation?
Yeah, that will deal with that tomorrow.
Sir, notes of week 3 and 4 are not available.
Yeah, weeks of week 3 and week 4 are not available at the moment. So basically, you just make them on your own. It would be better, but they are not available as of now.
Okay, thank you, sir.
Okay, there is one hand. I can see somebody has raised their hand. Fariha Naushin.
Excuse me, sir.
Yeah.
Sir, I have a query regarding one question. If it is okay, can I ask?
So basically, like this was just a revision session. We are like,
Not
you know that
technical
we don't have like we have the sessions, those problem solving session and a doubt clearing session.
Okay.
Yeah, this is just for a revision. We're not like doubts in this
Fine.
session. Okay. Even if you like, you can post it on the discussion forum or discourse, whichever one you have access to. Okay. We'll just end this meet. Thank you, everyone.